And we're live. Thank you, everyone, for joining the second workshop of FraxBuild, the Frax-based hackathon on DoraHacks.io. I'm joined today by Drake Evans, the lead engineer at Frax. We're very excited to have Drake with us today, and we're very excited to be hosting this workshop in conjunction with FraxBuild, which is Frax's very first online hackathon ever. If you're not already aware of this hackathon, you're not participating in it, it's a very unique opportunity for developers to get involved in the ecosystem of probably the leading decentralized stablecoin in the Ethereum ecosystem. We are super excited to offer this opportunity for you to participate. And we really just want to spread the word of this exciting hackathon because we don't really think there's any other hackathons currently live that have, tracks and opportunities like this. So super exciting for developers, lots of prizes up for grabs. Already some really solid project submissions, but we've got some time left in the hackathon if you haven't joined yet. So I'd encourage you all to do so on DoraHacks.io. Before we dive into the workshop, I'd like to just let you know, please feel free to ask questions in the chat. I'll make sure Drake gets them. You can ask either in the YouTube chat, Binance Live chat, or you can DM me directly on Telegram at Brian Dora. I'll make sure Drake gets them. And without further ado, I think we should dive in. Drake, thanks for being here. Drake's going to give us a technical workshop on how you can build on top of FraxLend V2. But before he gets into the technical stuff, please, if there's any initial words you'd like to say, the stage is yours.
Thanks, Brian. I'm really excited to be here. Really kind of happy to walk through some of the technical details of what we've been building. Today, I'll be focusing mainly on FraxLend, which I was the lead author on, and kind of walking through some of the stuff you might want to know if you're going to build on top of FraxLend. So I'm going to actually have or make an attempt to consolidate all my notes or anything that we kind of discuss and link to in a Notion page. I'll share that link now. Right now, it just has a few links in it. I'm going to send it in the chat, and hopefully it can get disseminated for you guys. Brian, can you see that link?
Yep, I can see.
Great.
I can see
Cool.
that.
And then, so right now, there's just a link to the repository, some other stuff that we'll kind of walk through. And if I have any notes or answers to questions and stuff, I'll populate that page over time. So let's just jump in. The first thing I think I'll do is probably just give an overview of FraxLend. So I'm going to share my screen and actually let's see if I can do this seamlessly. Let's see. Here we go. I think you guys are looking at the documentation now. Is that right? Perfect. Great. So this provides a nice overview of the ecosystem participants for a typical FraxLend pair. There's obviously borrowers and lenders, and there's a few other contracts that a pair might interact with. The first is going to be the Oracle, and this is something that primarily provides the pair with price data about the asset and collateral. Then we have the rate calculator. This contract is responsible for the calculation of interest rates. And then we have the deployer, which does the actual deployments. In V2 of FraxLend, the deployers are ephemeral and changing depending on kind of the needs of individual pairs. However, there is an additional contract, the FraxLend pair registry, which does provide a list of all pairs ever deployed. So if you're looking for an on-chain source of truth about pairs that have been deployed, the FraxLend pair registry is where you would find that. I've added the link to the registry to that workshop notes link on the Notion doc. So if you're looking for that, you can find it there. So I'll just kind of walk through. Let's see. Let me share that screen with you guys. Let me see. Yeah. So this is the contract for the registry, and there's a few functions which are going to be helpful for people who are looking to kind of programmatically access the list of all pairs. And that's going to be here, this get all pair addresses. And when you query this, it's going to provide you a list of every FraxLend pair that's been deployed. You can use this for statistics or to sort of onboard new pairs as needed. But I think this is going to be something that if you're building on top of FraxLend, it may be relevant to you. Let me just jump back to the different doc. Okay, so we're back to the sort of the overview stuff. So one thing that I think a lot of people have questions about is sort of how things work under the hood, but specifically around interest rates and about interest rates and the Oracle. And so I want to, after we do kind of an initial walkthrough, I'll be going into more detail about how you can, how those pieces work, but more specifically how you can access them from off chain, and how you can sort of interpret the data, whether or not it's stale, what does it exactly represent at a deep level, and sort of how you might consume that data in order to build on top of these pairs. But before we do that, I do want to just provide kind of a very loose overview of how FraxLend works. So FraxLend is kind of what I would call a...
Drake, I just want to jump in real quick. Just
Sure.
a few questions from the chat.
Yes.
So there you go. The question was if you are sharing anything on your screen yet, and I see it here now. So.
Oh,
perfect.
Great.
Okay.
Yeah, and also please feel free to jump in with questions. I want this to be kind of like a back and forth, less than a presentation. So anyone who's watching it has a question, please post that in the chat and we can sort of go where the audience wants.
Perfect.
Cool. So as I was saying, FraxLend is essentially a continuous line of credit over collateralized, and essentially uses the over collateralization as a tool for the health of a loan. And that this is a design that should be pretty familiar to most people who are in decentralized finance. And so I won't go too much into the details of that, but I will sort of, let's talk next about potentially the interest rate calculations. So let's just see here. We got there's some, and by the way, there's some really good deep dive into sort of the technical stuff on how the accounting is done on the docs page. I won't go into details now just because I think it's pretty clear on the docs already, but we do get a bit of questions about interest rates. So I do want to just kind of touch base on this. So FraxLend V1 used this linear interest rate, and you may be familiar with this concept from big protocols like Aave or Compound, who utilize something like this. And it's basically a simple y equals mx plus b. And there's two slopes here. And they call this the kink sometimes. I refer to it as the vertex. But the idea is that if as the utilization of the pair increases, the interest rate aligns on this scale. Of course, when things get too high, the interest rate can rapidly increase. And we incorporated this into the V1 of FraxLend. However, there is one sort of problem, which is that it requires constant governance oversight. So the part of the issue is that, the markets change and the potential risk profile of certain assets also changes. And in an attempt to address that, we introduced essentially what's called a PID controller. But what this basically means is that there's a shift every time, there's a shift over time, rather, depending on the current utilization. And so what the variable rate V2 interest rate curve does is a little bit of both. So this curve itself actually shifts in response to market forces. So what does that mean sort of in practice? Well, we define this kind of target utilization. And for most FraxLend pairs, that's 80%. Now, when the utilization is above this target range, this entire curve slowly will shift upward. The idea is that as interest rates rise, borrowers will be incentivized to repay their loans, bringing down the utilization rate. Alternatively, lenders may be enticed by the rising interest rates and choose to lend more value into the pair, again, bringing the utilization back to this sort of Goldilocks zone. So you can think of it like this. If you come in and utilization is 50% and you bring it to 75%, immediately the interest rate will change and it will slide along this curve. If after your transaction, the utilization rate is outside of the safety zone, this entire curve itself will slowly shift upwards or downwards. Now, the rate that this curve shifts is relatively slow, meaning I believe now if the utilization is 100%, most pairs would double every 2 days. So typically what we see is something like this, where the interest rate's just above this kind of cutoff point, and we see interest rates moving a few percentage in relative terms, of course, every day until sort of market reaches equilibrium. We've had a lot of success with this model, but it does introduce a little bit of nuance and complexity that is sort of unique to FraxLend. The nice thing is that we haven't had to constantly manage the curves for our pairs, and it's really reduced the governance load for the protocol. I'm going to just maybe pull up some code now to walk through the details of how these numbers are calculated. If there's another topic people want me to jump into, please put a note in the chat and we can sort of take a look at that as well. So let's just take a look at an actual pair. So we can take a look at, let's see, we can do the curve LP pair. So you can see here a link to the rate calculator. So the important function that we're going to call here is going to be get new rate. Now it's going to take a few parameters, the delta time. This represents the time that's passed since the last time we accrued interest. We're going to ask for the utilization, and we're going to ask for the previous full utilization interest. Now, this term, full utilization interest, oh, you guys can't see the Etherscan, can you? Give me a second. Sorry, guys.
Yeah, no, just the variable rate V2.
Yeah, that's okay. I'm going to just actually, this is something I do want to just talk about. So this max rate, which you have right here, is the variable old full utilization interest. And what it represents is the interest rate if we were at 100% utilization. Something to just keep in mind. Now, I will stop and I will share what I wanted to share a second ago, which is the Etherscan variable interest rate contract. So this is an example of a variable rate contract. You can see here the name.
Hey, Drake, there's actually a quick question if I can interject.
Yeah, I'd love it.
So it is there a simpler getter or lens contract to view V1 pending interest?
Pending, no. So this is actually an important a thing we can talk about, but I think it's actually very pertinent. So I will talk about kind of this, what we've described as like what they've described as pending interest and how you can access it on V2 pairs. Is the question more related to specifically V1 pairs?
Yes, it's related to V1 pending interest.
So you have to calculate it manually, unfortunately. And let's pull up some code and we can just kind of walk through how that would work. Because as we pointed out, V1 pairs have a slight issue. They were designed this way intentionally, but we didn't provide the helper contracts necessary to kind of view pending interest. And so what happens is you have someone who interacts with the contract today, and after their contract, all of the state is updated. And however, if nobody touches the contract for, let's say, 24 hours, you come along and you might read that state and it's giving you stale information. And this is normal for blockchain, right? It's how things work. But what we've done as a nice sort of workaround for V2 pairs is if you access this data, we do kind of a simulation for you, which tells you the pending interest. So the short answer is no, it's not possible to view the state from within V1. However, we can walk through kind of how to calculate that relatively easily. So let me just stop sharing. I will pull up some code and we can just take a look at how that interest is calculated. Great. So if you, let's see. So this is the latest code of Frax on Pair Core. And I'm just going to show how we calculate it and sort of display that data for V2. And essentially, you're going to want to replicate that same functionality for V1 to see the pending interest. So if we take a look for, let's see. So this is how interest is calculated. And we'll just kind of walk through what's happening here. And this code is available on the repo. I just pushed up code recently for V2. So that should be all up to date. And like I said, the links for that are in the Notion doc. But the way interest is calculated for V1 and V2 actually is essentially you have the time elapsed and you multiply that times the interest rate. And that gives you the total amount borrowed. And it's right here, you can see. So the first thing you would do to sort of calculate pending interest is you're going to get the rate. So on V1, or maybe perhaps it's just better to look at the V1 code. Why don't we just do that so we're not... So here's the interest calculation. And the first thing that, and this is kind of where the meat of it starts to happen around line 438. And again, this is just this code again is available in that repo. It's just one commit back. But yeah, the first thing you're going to want to calculate is the utilization rate and the elapsed time. So the best way to get the latest elapsed time is going to be to actually call current rate info. This is going to give you back a tuple or a struct, which has a last timestamp. This represents the last timestamp that the interest was updated. So if we just come up here to look at the storage layout, we will see, where is it? I believe it's called current rate info. Yeah. So this is going to be the getter, and it's going to tell you the last timestamp that you updated interest, and it's going to tell you the last rate that was being applied. Those two pieces of value are going to be important for our calculations. So I might just write some notes here, but the first thing you're going to do is get the elapsed time. Let me share a different screen now. So we'll just kind of do this in real time together. Share screen. Okay, so the first thing we're going to do is get the, so let me just see if we can get this all together. So we are going to calculate pending interest. So the first thing we have to do is get current data, get current info. Specifically, we want to know the last timestamp, and we want to know the last rate. So we'll pull that from the actual pair itself. So we'll do it like this. So here, let's do a V1 pair. So let's try the Weath pair. We will go to the pair on Etherscan, and we're going to pull that data. So let's just see here. We'll look at current rate info. We'll query that, and we see the last timestamp is given in seconds. So we'll put this over here. And we'll look now for the rate per second. This was the, again, all of this data is going to be stale, but we will jot it down. Okay, the next step is going to be to get the new rate. Because the interest rate is applied, let's see, here, great. So if we go back down here to add interest, we will see that, of course, my language server just crashed, so I can't have to do it the old way. Looking for, we'll control F it, that's fine. So you can kind of follow this through here, but first you have the delta time. That's going to be, we're going to use, right, like we hear, this last timestamp, and then we're going to use the new rate to calculate the, this is new rate, or this is the rate per second, and this is going to, we're going to call the rate calculator get new rate. Now, so we've calculated delta time, right? This is the value for how much time has elapsed between the time you want to calculate the pending interest to. If that's right now, it would just be the current timestamp. If you wanted to calculate pending interest into the future, you would, of course, use the future. You have the old rate per second, which is, we just pulled from that same getter. Now, the utilization rate, the best way to get this is going to be, again, from Etherscan. So you can use, let's just, right here. So you're going to want to pull two specific places, two pieces of data. Let's see. There's going to be the total borrow. Nope. Let's see. Total borrow. And this top line number, the amount. And then we're going to do total, and the total asset. So total asset represents the total amount of assets lent to the pair. And the utilization is going to be the amount, or the amount borrowed divided by the amount lent. So let's see. So we'll actually get utilization next. Get utilization. Let's see, let me just switch this back to OneNote. So the next thing we'll do is get utilization, and that's going to be total borrow dot amount, and we'll need total borrow dot, total asset rather, dot amount. And we get those both from Etherscan. Now we'll jump back into the code. And now we'll pass that value to get new rate. Get new rate will calculate that and return to us back sort of the new rates. At this point, we now have the data required to calculate the interest earned. So I made a mistake, actually. So we can actually simplify this process. So the interest rate, okay. No, I did not make a mistake. Scratch what I just said. So there's one important line up here I want to just draw lines to. We calculate the new rate, which we use a utilization, the last timestamp, and the last rate to do. And we're overwriting this value. So this in-memory value now represents the new rate we just calculated. So together, we now have enough information to calculate our interest earned. So we have the amount of time that's elapsed, we have the total borrow amount for the entire pair, and we have the new rate per second. We multiply those together, and this gives us the total amount of interest earned. Now, the third and final step, once we have sort of, let's see, well, let me just come back to OneNote so you can see. So for calculating pending interest, we're going to get the current info, we're going to get the utilization, we're going to get the new rate. We're going to feed these two things into here to get the new rate. Then we're going to need to go to get time elapsed. And lastly, we calc total interest earned. Now, this represents the total interest earned for the entire pair. So what you'll need to do is essentially calculate the amount. So this is for the full pair. If you want to calculate your share of that, you'll do it in the following way. You'll basically take total interest divided by total borrow, and you'll multiply it by the user borrow. Wait, sorry. It'll be like this. We'll do it like this, actually. It should be, this is wrong. I apologize, guys. Let me find my eraser here. Sorry. You'll take the total amount that you've borrowed and multiply it by the total interest plus total borrow for the pair divided by total borrow for the pair, like this. And then this is going to give you what you owe. So if you want to, this will give you new balance. And then if you want to just get the delta, it's just new user balance minus original.
Hey, Drake, do you mind
Yeah.
scrolling down a bit for the audience?
Oh, yeah, I was scrolling down on the wrong screen. Sorry about that, guys. So let me just give you a walkthrough because that was my fault. Sorry. So the first step is we get the current info, which is the last timestamp and the last rate. We're going to get the utilization by calling total borrow and checking the amount, and by calling total asset and checking the amount. We're going to use that information to get the new rate. It has to be ABI encoded, but you can look at the way the repo does that. After we have the new rate, we'll calculate the time elapsed. Now, the time elapsed is equal to basically now minus last timestamp from above. And basically, we take the data from this last timestamp, and that's down here. And then we can calculate the total interest earned. I apologize, guys, for not scrolling down. That was bad. Thank you for letting me know. So then to calculate the total interest earned, you take the total amount the user has borrowed times the total interest accrued, which we calculated up earlier. And then we multiply that times the total borrowing, or add that to the total borrow, divided by total borrow again. And this gives us the new amount the user owes. And if you want to just know the pending interest, you take the new user balance minus the original user balance. And I'm going to call those user borrow just to kind of keep the notation similar. Does that make sense to people? I hope. Any questions on that? And I will add this page to the Notion doc as well. Is there a way for me to?
Yep, Drake, and just so you know, the Notion doc has been shared in the chat of this workshop. If anyone is reading the chat, you'll see it there. It's also been posted on Twitter as well as a direct comment to the workshop announcement. So you can find it in both places to follow along.
Hey guys, can you hear me? I just got.
Yep, we can.
Okay, great. Sorry, I just had a phone call come through and it booted me off my audio. Yeah, thank you for doing that and making sure it's sort of disseminated. That's great. And I will add this as an image probably to that notebook. So yeah, let me just, any other questions on this, or I'll kind of jump back into some other pieces I wanted to just walk through. Okay, cool. Let's see, we were here, I think. Interest rates. Yeah, so I will just kind of walk through maybe the interest rate calculations for how this works. Let's take a look at here. So if we take a look at this code, oh, you know what? We can do it here like this. Yeah. So there's two, you can kind of think of this as two distinct operations. The first is getting the full utilization rate. And remember, we talked about this as being this max rate. So this max rate is what's going to sort of drag this slope up and down. And that's based on the utilization being too low, below 75%, or too high, above 85%. Under those circumstances, this value here is going to tick upwards, and the graph, the entire graph will scale. The minimum rate will always remain the same. So the effect that this has is creating a steeper slope. So if we come and just take a look at this code, we can kind of see how this happens. So you can see we call the function the pair calls get new rate. We pass in the time that's elapsed, the utilization, and the old full utilization interest. The first step is going to be to calculate this new full utilization interest. And this is going to be based on, as we discussed, whether we are inside or outside of the ideal ranges of utilization. If you're above it, this number will increase. If we're below it, it will decrease. And then after that, it's pretty straightforward. We just follow along the slope. So this number will this slope will be adjusted. And after that point, it's simply just y equals mx plus b. We put in the utilization, we add the y-intercept, and we calculate the point in time. So we hope it's a significantly easier process this way. We've switched from bytes to individual values and done our best to kind of simplify this. These commented out codes are sort of the expanded version of these calculations. They should be pretty straightforward, but they're simplified to this below just for gas savings. So that's how interest rates work. Unlike the V1 pairs, the V2 pairs have some convenience functions which you may find helpful for previewing pending interest. So let's just take a look at some of those. So the nice thing about the V2 pairs is that they adhere to the ERC 4626 standard. And so they provide previews for all of the things you might want to calculate. But in addition, we've provided some more functions for the same purpose. And you can see here this preview interest. So as you convert between to borrow amounts to borrow, you'll see that these values now include your interest. So let's just kind of walk through how that works. Every user's interest is represented as shares under the hood. So what that means is that the number of shares that you have, borrow shares, I'll call them, is always fixed. But the amount you owe to repay those shares is what's always increasing. So that's the amount value that we talked about, and the shares are fixed. So if we take a user, I'll just use my test address. I do believe I have at least one borrow on this pair. You can check my balance by calling, let's see, the user borrow shares. So we'll just put in my address here. And this is going to give us how many shares of borrow debt I have. So this is the number. So we'll take this, and I want to know how much I owe today. Now, if I were to check, if I were to use the sort of old calculations, I would be using stale data. But now I can calculate the exact amount that I owe by using this to borrow amount function with the preview interest Boolean. So the old V1 pairs would have given me this number here. And however, we want to simulate pending interest. So I'm going to set this to true, and you'll see this number increased. And that's to represent the interest that I owe up to the point in time today. So this is significant improvement in terms of user interface from the V1 pairs, and inspired by the ERC 4626 standard. Another thing you might find useful in terms of adding, in terms of interest accrual, is this preview add interest. So this is going to preview in the same way we previewed before the interest. So you can see since the last interest accrual, this is the total amount of interest that has accrued. This would be the new rates, new current rate information. And this is going to be the total asset and the total borrow, what they will look like into the future. Meaning, so this kind of gives you all of the accounting into the future, accounting for any interest which would be accrued the next time somebody touches the pair. And you can see here this fees amount and fees share. This represents protocol fees. We don't have any fees on these pairs, so it's set to 0. But so I think that kind of, and this was great because this was actually exactly the type of information I wanted to cover in terms of the technical details. This is probably a question we get the most, is about how to sort of get access to real-time data. So if you're building a Dune dashboard or something else, this is kind of what you're going to want to look at. And then again, we have lots of these other preview functions that adhere to the typical ERC 4626 standard. Well, so I think that actually covered quite a few things on my side in terms of what I wanted to talk about. I have a few other thoughts on things we can run through. I have some ideas about maybe things people might want to build on top. But I kind of had listed down as things to talk about: interest rate calculations, Oracle calculations, reading state, liquidations, and flash loans for one-click leverage. If any of those, we've kind of walked through reading state and the interest rate calculations. But if there are other topics people want to touch base on, I'm happy to go into further detail.
I think that anything that can be like in terms of like what can be built on top, I think that would be great to chat about.
Yeah.
And then if anyone else, has wants you to expand upon any of the other things you just listed, like flash loans, etc. If anyone else mentions one of those in the chat, I'll let you know.
Sure. So one thing that we do offer is the ability for one-click leverage. And there's sort of a few ways you could implement this. We have it implemented as, let me, where's a pair? So there's a few things that we can do here, right? So I'll talk about kind of 2 ways to implement one-click leverage. And also what's perhaps even more important for people is one-click repayment. So we can talk about that too. So let's see. What's the best way to do this? Yeah, so let's just take a look at this code. This. Yeah, okay, so let's take a look. So there is this function leverage position. Now you can provide a...
Hey, Drake, before you dive too deep into that,
sure,
we do have one extra question.
Okay,
which
yeah.
is, or maybe just a clarifying question, but it is, are V1 markets no longer going to be launched since V2 are active now? And are further upgraded versions coming?
So yeah, all new pairs will be V2. We have a few V1 pairs that are actually pretty big. Let's just, so I would say the V1 pairs are the WETH, WBTC, FXS, and CVX and CRV markets. Those are all V1 pairs. And I think we will probably migrate them over to V2. Yeah, there's not a big timeline. And of course, it's always difficult to get people to migrate. So, but there's a lot of advantages for the V2 pairs. So specifically, the interest rate model is much better. So if you have followed these pairs closely, sometimes the interest rate can make big moves very quickly. Recently, we saw the CRV rate jump above 25%. And the original design of the interest rate curves was a little bit, required a bit more active management and was a little bit confusing. So that's the big piece. The other thing that we've done is we've moved to a dual oracle. So This is actually somewhat important, and maybe I'll just kind of sketch out something for people here. But the idea with the dual oracle is, let me just share my screen or move over my. So we now have two price sources. You've got your main oracle, and it actually is pulling data from two different places always. So typically that's going to be Chainlink and a UniV3 TWAP. Now you call get prices, and you're going to get three pieces of data. You're going to get information on if any of the data was stale. You're going to get a low price, and you're going to get a high price. Now, if you, and there's a few reasons we implemented this. So the first is it's always scary to have a single source of truth, even if it is Chainlink and they've got a great reputation. But we've seen where in extreme events like the UST DPEG or a few other few other events where Chainlink gave incorrect data, whether that was didn't have prices that went low enough, which I think would happen with UST, or even sometimes the data can be stale. And so what we now do is we require two sources of data. Now, what that means, and I think there's actually a few things that have implemented this design almost exactly. Probably the most famous is the Curve USD oracles. Mitch asked us how we were kind of doing this and implemented something almost exactly the same. And also more recently, Curvance is also going to have sort of very similar oracle design to this as well. But the way it works is essentially you get two prices. And in order to borrow, well, let me just state this first. In order to borrow, you have to have both of these prices. We take the worst price and we use that for the collateralization calculation. What that basically means is that in order to have an advantageous price for borrowing, you would have to manipulate both oracles. So not only manipulate the Chainlink oracle, but also manipulate the TWAP. And more importantly, perhaps, is that if these two prices deviate by more than 5%, all borrowing's halted. So this actually ends up creating quite a bit of protection. And if you look at most of the oracle hacks or price manipulation issues that lending markets have had, something like this would have stopped it, right? Whether that's even if the second oracle is not a Chainlink, you would require sort of twice as much capital to manipulate oracles in order to do something like this. So this provides a lot of protection. Now, the downside to typical designs like this is that you may lose out on liquidations. So to alleviate that, there is no deviation threshold for liquidations. However, again, you would have to, in order to manipulate liquidations, which is a significantly less profitable exploit scenario, you would again have to manipulate both prices. So we use TWAPs that are full range liquidity. If you're familiar with sort of oracle manipulation theory, right, it's difficult to manipulate. Well, it can be under certain conditions very easy to manipulate UniV3 oracles because of the concentrated liquidity. If you're outside of the range of liquidity, it becomes very cheap. So we always have protocol owned liquidity inside of the TWAPs to ensure that there's always some full range. And this makes the cost of exploits significantly higher and almost impossible to achieve. On the other hand, the liquidations always function regardless of the deviation. However, both prices would need to be below the liquidation threshold. So you'd be needing to manipulate multiple sources of liquidity. And again, those are always TWAPs or exponential moving averages in the case of curve pools. And just to clarify, yeah, there are some curve pools that have some reentrancy exploits or other things. Of course, we do a deep dive of every oracle we consume, and none of the oracles that we consume have these issues, just as a side note. Okay, I think we covered that. Let me jump back to, maybe now I can talk about the flash loan ideas.
Sure.
I think one of the big things that people want are typically, and services, I think something that people want. I think there's two things that it would be interesting to build on top of. The first is sort of like a yearn strategy or some type of management where, you lend Frax into this pool, and it manages positions across several Frax lend pools. So if you look here, these rates are constantly changing. Right now, CRV is quite high. It was at high utilization earlier. Sometimes the geom is higher, but you can see there's quite a bit of variability here. So this is a sunset pair. There's a 50% charge on the APY. So don't incorporate the sunset pairs, but yeah, I mean that could be a really useful thing to build on top of this. But something that I think is a little bit more fun and perhaps technical is like a flash loan type of one-click leverage. So there's two ways to do this. The first is going to be actually to just look at the, we have this ability sort of internally. However, it's a bit limited. So I'll just walk through how that works. So, and for those who don't sort of know kind of the basics of what I'm talking about, typically what can happen is someone wants to enter a position. Let's say they want to borrow, they have, they have $100 of CRV. They want to borrow 100 Frax, and they want to then take that 100 Frax and add it to their collateralization. So what they would have to do now is deposit their $100 of CRV, borrow $75 of Frax, sell the $75 of Frax, put that into CRV and deposit as collateral, borrow more Frax, until finally they were able to kind of complete the loop completely, right? However, there is a built-in way to do this in we have this function called leverage position. I won't go into the details of this function because I think it's not really something to build, but I will kind of just run through what's happening. So what's happening here is actually you provide a swapper that adheres to essentially the Uniswap v2 interface, and you essentially say, I want to borrow $100 of Frax. I'm going to put in initially $100 of CRV and take that whatever I borrow and just load it up as collateral inside of my position. So what this does under the hood is does the swap for you. And it does that swap through whatever swapper you provide, as long as it adheres to the interface. So these swappers are whitelisted contracts because, of course, sending and making transfers on an external contract is potentially very malicious. So there's two routes that you could go to build on top of this. One is you could build your own swapper that routes significantly better than through a single pool. By default, we have FraxSwap pools whitelisted here. However, if you wanted to provide one-click leverage through a Uniswap v3 pool or a Uniswap v4 pool, or you wanted to multi-hop across a bunch of places, right? You could do that by designing a swapper that just adhered to the Uniswap v2 interface. Now, you would have to make a governance proposal to have that whitelisted. But again, I think we're very open to that. What's also an interesting idea is to provide a flash loan contract. And the way that would work is you would just do the same kind of, you'd call the same functions, but from this flash loan contract. So a very interesting thing might be to provide both winding up and unwinding, right? And I think unwinding probably has the highest amount of use cases for people. So because people want to quickly, a lot of times, pay down their, LTVs are creeping up. They're worried about getting liquidated. they want to basically do a soft liquidation of themselves. And in that case, you could use a flash loan for this. And essentially what you would do is flash loan the borrow or the Frax to repay it, pull out collateral, swap that, and use that to repay the flash loan. So I think that's another area that could be really useful. People would have to take out their initial position from within the flash loan contract because you can't borrow on behalf of other people. But if you took out the position initially under a flash loan contract, it can be unwound the same way. So I think that actually provides a lot more flexibility than the built-in leverage position. So I would love to see someone build something like this on top to provide kind of significantly better execution for the swapping, but the same kind of one-click leverage, which is nice because it doesn't require a bunch of capital up front.
That is really cool. Yeah, you heard it here, folks. Like, if you're looking for a good hackathon idea, Drake just gave you one. So bear that in mind.
Yeah, there's also like I have some other things on here, like liquidations, which I think have the potential to be fun to build on top of as well. I had some people who were reaching out wanting to use kind of gelato for that. Yeah, I think there's a lot of cool ideas here. And so, yeah, if anyone has any questions or thoughts, I don't know how long this is supposed to go for, but
yeah, it's flexible.
Okay.
But
yeah, I actually realize I have something at
okay.
this time, but any final questions that I can answer, would love to do that.
Yeah, I don't see anything in the chat at the moment.
Okay.
But if maybe just give people the best way to reach you if they have any follow-up questions.
Find me on Twitter, Drake Evans V1. Or you can tag me in the Frax Finance chat, although that's hit or miss. It's probably better on Twitter, to be honest.
Okay. Hit him on Twitter. Thank you so much.
And I will update that Notion doc with these sketches I have here so people can take a look.
Okay. Yeah, I think it would be great probably to upload it to our hackathon site as well.
Oh, yeah, that's great.
We'll make sure that's done. That way it's in one central place for everyone, just in perpetuity. Because I agree, it's definitely going to be a great resource. I think this was a really informative workshop. So thank you for taking the time to share it with both of our developer communities today. I think it will definitely lead to some good submissions. Probably inspired some people that are thinking about jumping in as well.
Great. I'm happy.
All righty. Well, if that's it, thank you so much, Drake, and we'll let you jump to your next meeting of the day.
Thank
you. Everyone in the audience, thank you for joining the second workshop for FraxBuild on DoraHacks.
Cool. Thanks, guys. Bye.